Esteemed guests, good day. Let me now to greet everybody on the masterclass of our company. This is IHC Mining. We're within the group Royal IHC, and the topic of our masterclass today is devoted to the innovative methods of hydromechanized mining. So what we have today, the mining and hydro transport and combination of this method and application of different type of equipment and other aspects of mining of the solid deposits, mineral deposits. Just shortly, I would like to introduce our company. We are the largest and the oldest in the world, and maybe the only leader in production of large hydromechanical equipment. The history of the company goes back to, I have some nice pictures here with me. So the history of the company started practically in 1642. This is the 15th century, no, 17th century to be exact. I made a mistake, just a very little mistake. So the company, it's a Dutch company, and we have a head office in the Netherlands. And you can see our, way we started in the 17th century up to the present days. We were the first one. As you know, Holland is on the seashore. And when we apply it to the gold mining, we use the different types of the dredges, and we use them, these bucket ladder dredges. It appeared first time because we have an idea to place it on the Pantheon. And the first dredge appeared in the beginning of the last century. It means 1906. Some of them are still used. They operate in Amur region and Krasnoyarsk region. And today, I lose my picture, unfortunately. My nice pictures, they go from... Currently, we are the global company. You can see here we have about 2,500 employees, and here you see the figures, the millions of projects that were implemented, and I want to draw your attention to more than 80 vessels were built at partners' yards. So our company operates in different areas. First of all, what we call dredging in English, and in Russian, that is mainly correspond to the standard workings and equipment used for hydromechanization, different type of deepening the bottoms. Also, we work working with the channels and the required infrastructure that is also produced by our company. Next area of our operation is the offshore energy and also deep water energy. Then mining of solid minerals, and the new area we joined it just recently. This is the shipbuilding in defense industry. Now coming closer to the topic of our masterclass, I would like to speak about two most important statements. First of all, there's an opinion of the experts of our company, those who go deep and those who work closely or involved in mining of mineral deposits, and also they are related to the equipment and infrastructure. We have also a separate department. This is Consulting Mining Advisory Services. Why I make this stress on advisory? Because unique technologies or equipment that we have must be applied to the specific projects, to the specific deposits, to the flow sheet of the company. So it means we monitor the project from the very beginning, from the exploration stages up to the mining, optimization of production, increasing of the level of production and productivity. And now we already accumulated a very vast experience, global experience, while working with man-made deposits. tailing deposits. And within our masterclass, we are going to share this knowledge with you. Coming back to the statement that I was going to open, there is a topic very well known to all of us, that water is something which prevents us from doing something. And many companies that apply traditional techniques and traditional methods, they think that water is a kind of enemy, a foe, and they have to fight with it. But the idea of our company and our innovative technologies, both for equipment and mining, they are related to the fact that water can be beneficial, and it's not disturbing us, but it helps us, it assists us. And when you listen to our speakers, I would like to, again, to have this discussion, but after the presentations. Now I want to give the floor to our first speaker. This is my colleague, Feldman Nguyen. He is the director of IHC Mining, and he is responsible for international activities of the company. And of course, Russia is within this, and the CIS countries are also under his responsibility. Hank will be making his presentation online, but he will gladly join us later, and we'll have Q&A session after all the presentations that will be made. So the floor is given to Hank.
Very grateful that I get some time to present my thoughts about wet mining. And in this presentation, I will expand on the IHC experience in innovative wet mining equipment for different commodities, but specifically for gold, and try to translate this globally developed knowledge into more specific applications in Russia. After a short intro, I will present some important thoughts on the selection of equipment based on different project constraints, both for dredge mining as well as for processing equipment. This selection process can then be highlighted in several cases for wet mining and possibilities for processing solutions. Finally, I will end my presentation with some conclusions. Wet mining is actually based on the use of dredge mining equipment for land-based deposits, marine, near-shore deposits and deep-sea deposits. Land-based and near-shore operations aim at mining placer or alluvial deposits with gold, tin and diamonds. Aggregates winning for sand and gravel can be grouped here as well. Focusing on Russia, this presentation will be on placer deposits and man-made deposits. This last type consists of crushed and milled material that is processed with water and primarily deposited as slurry. This makes this material very suited to dredge mining. Concentrating on gold, the man-made deposits can be from alluvial mining projects and/or hard rock operations. Dredge mining equipment offers single unit high operating capacities and the possibility to connect the mining directly to a first step processing. This processing is mostly based on gravity separation, although other physical means like magnetic separation and/or hydrometallurgical methods are used as well, either alone or in combination. A proper operation can only be run if the selection process of the required methods follows a clearly defined approach. Based on a long history as supplier of this type of equipment, IHC has a lot of experience and possibilities to define solutions for wet mining projects. There are a huge number of different dredge mining methods available. This also accounts for processing possibilities. What type of solution should be used is determined by the deposit characteristics like particle sizes, consistency and deposit layers, weather and other site conditions and project circumstances like required capacity, operational depth and sustainability issues. Let's first focus on dredge mining equipment. Following a proper selection process for this type of equipment, we should look at the different processing steps of the dredge mining process as shown in this sheet. This begins with cutting and slurrification, or picking up with a bucket, vertical and horizontal transportation, and further processing or depositing of the material. Forces generated by the operating movement and cutting action of the equipment have to be taken into account, as this determines the operational window within the design capabilities of the equipment. We can connect the different processing steps of the available type of equipment with the project constraints, and this provides us with an overview of operational possibilities as shown in this sheet. We basically make a difference between mechanical dredges and hydraulic dredges. Mechanical dredges, like a backhoe excavator, a grab or a bucket ladder dredge, use buckets. The hydraulic dredges use centrifugal pumps to allow slurry transportation. Further on in this presentation, I will discuss differences in more detail. A similar approach can be followed for processing solutions. Basically, we differentiate between feed preparation and material handling. Primary separation, in which we separate the valuable minerals from the matrix material, and secondary steps in order to separate the different valuable minerals from each other. Different steps are available, and again, depending on project constraints, we can decide what type is best suited. More and more, tailings disposal and dewatering are becoming more important as steps to be taken into account. As an example of selecting the right type of equipment, I will use gravity separation. Possibilities are basically defined by particle size distribution as shown in the graph of the concentration criteria. This so-called CC can be calculated as the relation of apparent densities of two minerals to be separated. The higher the CC, the easier gravity separation for a smaller particle size. A number of different methods and applicability for size ranges is shown in the lower graph. This applicability is not only governed by the particle size, but also by the operational possibilities and equipment design. When gravity separation is not possible anymore, other methods using other mineral parameters should be used, like magnetic and electrostatic separation. If this is not possible, then hydrometallurgical separation or a combination of all methods can be used. This often becomes a more complex flow sheet as milling, screening and classification becomes necessary. All in all, the best selection is to use the most simple setup within acceptable performance. Applying the selection process on dredge mining equipment can be further explained by some case histories. First, mechanical dredges. Suited for a large particle size, they are efficient for alluvial mining projects. As the mechanical method only has limited horizontal transportation capabilities, all the methods should be used for onwards transportation. Following the experience in Russia for alluvial gold, bucket ladder dredges are often applied. This is an integrated dredge, combining dredging and processing operation on one vessel. It used to be the workhorse in dredging industry, very reliable, good cutting performance and applicable for larger particle sizes. However, the conventional bucket ladder design goes with high operational costs due to a lot of maintenance. As innovative development and replacement of the conventional pin-bush connection, we started to use a track system to which the buckets are bolted. This allows replacement of the buckets in much less time, whereas the track system drive uses a sprocket system, which uses less energy and requires less maintenance. Such an innovation undoubtedly could be used in Russian gold mining, as these systems can be installed as part of a renovation project. When deeper dredging is required, we can use a grab dredge. With lower operating costs, the grab dredge is an interesting possibility. However, due to its flexible connection between the grab and the dredge by wire, less applicable for higher cutting forces. Compared to a grab, a backhoe excavator can generate very high cutting forces, is very selective and accurate due to its solid construction and therefore very versatile in its applications. Larger depth units to 25 meters exist, but to keep these units within an economic design, a larger capacity is required with larger bucket sizes. Within the dredging industry, the hydraulic type of dredges with centrifugal pumps for slurry transportation are mostly used. For mining projects, the stationary dredges like a cutter suction dredge or a wheel dredge are mostly used. This type of dredges swing around a spud and can operate at larger capacities. Using underwater pumps allow larger dredging depths. However, with the larger depth, also larger forces have to be compensated in design capabilities. The cutter dredge uses a range of different types of cutters depending on soil conditions. It can generate high cutting forces, but is less suited for cohesive type of soils. Depending on the swing direction of the ladder, the cutter head operates either in an overcutting or undercutting mode. Depending on the soil strength, this can result in a difference in cutting production per swing side. The wheel dredge operates with an equal cutting operation to both swing sides, but is somewhat less suited for real hard material. Due to its design, with a scraper lip in between a row of bottomless buckets, the wheel dredge can be used in cohesive soil and generates high slurry concentrations. It is therefore very suited to be used in operations with directly connected plants. Modern dredges can be used in Russian gold mining applications. The innovative chain-track bucket ladder dredge can be used in alluvial mining projects as integrated unit with a complete processing unit aboard or with a coarse screening step aboard to get rid of the coarser material. In that case, the finer sized gold-containing fraction can be pumped onwards to a floating processing plant. This allows a very flexible operation in which each unit is used for its design purpose. The dredge only dredges and does not have to carry all process plant weight in its swinging operation. The separate plant can be operated efficiently with other movements than the dredge. Using the operational benefits of different types of dredges can be used by applying them in mining different layers as shown in the middle picture. A hydraulic dredge is used to remove an overburden layer at low cost due to its high capacity and transport possibilities over longer distances. A bucket ladder dredge is used to mine the gold-containing layer. In the bottom picture, a wheel dredger is used to directly feed a floating plant. In this case, the wheel dredger replaces a backhoe dredge for its large capacity at lower costs. The use of different dredges for different duties in a mining operation is further explained in this sheet. A cutter dredge is used to remove an overburden layer, which is then pumped over a large distance and deposited behind the bucket ladder dredge that is used to mine the gold diamond layer. In this way, both dredges are used for its best performance, the cutter dredge at a large capacity plus long distance transportation, and the bucket ladder dredge to mine the pay layer accurately and over a longer time as it does not have to remove the overburden. In this way, the sequence of the different layers is not disturbed and overburden can be displaced in contained areas without releasing slimes to the environment. Overall, this provides more minerals at lower costs. A similar approach is followed in this gold mining operation of Mineros in Colombia. However, here wheel dredges are used to remove the overburden. Due to the high clay content of the overburden, a wheel dredge is much better suited for this soil. As the wheel dredges remove most of the overburden and transport it over longer distances to a place where it will not release clayey material in the water, the process water for the gravity jig system has a better quality. This improves recovery of the gold, and with less time to remove overburden, the bucket ladder dredge produces much more gold. The result is a higher output of gold at lower costs. To highlight some possibilities with innovative processing equipment, I want to present the capabilities of the innovative IHC high recovery jigs. These jigs are based on a modular design, which depending on capacity can be arranged up to a full circle. The feed intake in the center allows even distribution over the jigs, and due to the unique sawtooth stroke, very fine gold can be recovered. The trapezoidal shape reduces the water flow over the bed, improving on capture of the small-sized gold particles. Some of these jigs have been used or are in use in different gold mining operations in Russia. In order to improve the gold recovery on bucket ladder dredges, the IHC high recovery jigs can be used to replace existing lower performance systems aboard of Russian dredges. This picture shows such an installation with two full circle jigs as primary step, 2x3 IHC module jigs as secondary step, and one module jig as a tertiary step. Arranged in a so-called closed circuit, gold recovery can be enhanced, as misplaced gold particles get an additional chance for recovery. Besides the higher recovery, the ratio of concentration is also improved by using a closed circuit. It will be clear that gold can be recovered from man-made deposits. Here we can use the IHC experience of other processing applications around the world. Based on our experience in heavy minerals industry, we can use a combination of jigs and spirals in which the jigs are used as pre-concentrator to recover coarser gold and the spirals to recover the finer sized gold particles. Adding a milling step, including classification, allows the use of hydrometallurgical means to recover gold from intergrown particles or too fine sized gold that is not recovered by gravity methods. In that case, IHC brings in the gravity separation expertise and our partner Tetra Tech, the hydrometallurgical knowledge. To finalize my presentation, I would like to close with some conclusions. As Russia has a lot of gold mining opportunities in alluvial deposits and man-made deposits, a lot of opportunities exist. A number of these opportunities require solutions not available in the Russian supply chain. IHC and partners are more than happy to assist. This can be done with dredge mining equipment, either separate or as integrated equipment, with processing steps aboard, or also with processing equipment alone being fed by dry mining methods. I trust to have been able to show you that a proper selection of the equipment and methodology is essential to define the best solution. This can result in a higher outcome at lower cost, not only based on the use of innovative equipment, but also by using an innovative operational setup, changing long-time habits to more modern ways of operation. I'm happy to answer some questions.
Thank you very much. We expect a good productive discussion after all presentations are finished. Уважаемые господа,
Dear ladies and gentlemen, now we want to introduce the next speaker, and the next speaker is Stefan Gronheide. He will speak about the hydrotransportation in combination with different types of mining, wet mining and dry mining. It's quite a vast topic, a lot of material, you know. It's very difficult to put all the material within 15 minutes because every chapter, every topic requires the expansion of the topic. But in any way, I give the floor to Stefan Gronheide. He will be also online and he will join us later for the Q&A session. Thank you.
Hello and welcome. Thank you for attending this masterclass organized by IHC Mining for MINEX 2021 in Russia. My name is Stefan Groenheide. I'm a mining consultant working for IHC Mining Advisory Services in the Netherlands, where I specialize in mine tailings rehandling and slurry transportation. And today I will address the topic of IHC Mining's innovations in hydrotransportation techniques and equipment. The table of contents of my presentation will be as follows. I'll start off with an introduction. I'll address something about wet or dry mining of man-made deposits. I'll address one of the innovations of IHC Mining, the tailings purification unit. I'll go into slurry transportation, especially over large distances and large elevation differences. And I'll wrap up the presentation with an example case and some conclusions. The majority of this presentation will focus around the remining of man-made deposits. Recent research has shown that over 18,000 of these deposits exist worldwide, and approximately 3,500 of these are active. And we also see a lot of these man-made deposits in Russia, since Russia has a very broad and long history of mining different mineral commodities, such as alloy metals, base metals, and precious metals. But what we see lately is that a lot of these man-made deposits are associated with challenges. We have seen breaches and failures of these dams, for instance in Brazil and in Canada, but also cases of groundwater contamination, acid mine drainage, and other environmental problems are known, which put a lot of public attention also on these man-made deposits, and last but not least, the post-closure costs that are associated with managing these deposits after the mining has stopped. However, where there are challenges, of course, there are also opportunities. What we see in these man-made deposits is that they have still some very good grades for primary minerals due to low recoveries in the past on the one hand, and also improved mineral separation technologies developed in recent history. What we also see is that they can have a very good grade of secondary minerals that were not even recovered in the past. For instance, you see that in copper deposits where the tailings contain still significant grades of cobalt that were not of interest in the past but currently have a high market value. And low-grade material can be used for blending purposes, what you, for instance, see in iron ore mining. If you want to do anything about it, take advantage of the opportunities or do something about the challenges, you need to have integrated technical solutions that are cost effective. Going to the deposits a bit further, not all the man-made deposits are the same. And of course, it goes also for conventional deposits. Some have a water body on top, and then basically the only solution is to use dredging and slurry transportation to remine these deposits. On the other hand, we can also have completely dry deposits. This is, for instance, an example from South Africa, where they use hydrosluicing to erode the tailings material to a sump, and from where it's pumped to a processing plant. However, there are also a lot of cases where the situation is in between these cases, where you have not a water body on top, but still the material is completely saturated, so you're operating in a swamp-like environment. Do you want to then go into conventional mining, where you use truck and shovel mining to remine these deposits, or are there better solutions? Well, so IHC mining, we think there is a better solution. Therefore, we developed the tailings slurification unit. As we see that slurification and slurry transport in particular is very suitable for these types of material. Slurry transportation is very suitable for material that is already fine, so sand-like, soil-like material. So this can be applied in both rehandling of man-made deposits, but also in, for instance, alluvial deposits. Slurry transportation has proven to be a very low-cost transportation method, which is what we're aiming for. And our design for this slurification unit is based on proven dredging technology that is developed within IHC mining. Some of the advantages before I go into the working details of the tailings slurification unit is that it's it's cost effective, as already mentioned. It has a low carbon footprint because this single unit can replace an entire truck fleet. So you also need less operators, which increase the safety of your operation. And it is suitable for operating in situations where there is low bearing capacity. We are currently developing and engineering this prototype, and we hope to have an operational unit in 2022. The tailings slurification unit is fed by a conventional excavator that drops the material here in the feed chute, where there is a horizontal grizzly screen positioned. In this picture here, it's in a vertical position to empty the grizzly screen. From there, the material falls into the slurry bin that is located in the hull of the unit, and from there, the material is mixed with water before it's pumped out of the unit to the discharge slurry lines, as you can see here. Well, to go into a bit more detail about the key characteristics of the slurification unit. The design is based on a standard sea freight container, so therefore it's modular and easy to transport. We aim at a production rate of 125 to 250 cubic meters of in situ tailings per hour. And we would like to pump with 30 to 50% weight percentage slurry concentration, which will result in a total flow of 1,200 cubic meters. In this tailings slurification unit, the newly designed HRHD series pump, centrifugal pump of IHC is installed with an 800 kilowatt electric motor. One of the key benefits of the HRHD series of IHC is that it can pump with a manometric head up to 15 bars, which is much higher than conventional centrifugal pumps. The grizzly screen is there to catch any oversight, which can be tilted to a vertical position to empty it, and we have different undercarriages available, so like non-motorized tracks or a sliding skid. The tailings slurification unit is As we already mentioned, slurry transportation is very suitable for sand and soil-like material, which can be found in these man-made deposits. And the slurry transportation is based on the Bernoulli equation, where basically taking into account all the friction losses due to the pipeline resistance, and therefore you get a pressure drop over the entire system. However, during the operation, we would like to see a constant flow and a constant concentration, because we directly want to feed the material to a processing plant to take advantage of all the opportunities that exist with these man-made deposits. However, that man-made deposit will then be excavated in layer by layer, increasing the geodetic head over the life of the operation, and also increasing the distance from the processing plant. However, we still want to have that constant flow and constant concentration. Therefore, the pump and the TSU is equipped with a variable frequency drive, allowing the pump to have a very broad range of working points, and therefore you can have a lot of different operational positions without changing the pumping system. Here I have a very short example case that we did for an iron ore operation, where we would like to pump 250 cubic meters per hour of material at a volume concentration of 25%, which equals 45% in weight. And again, the goal is to have a constant flow and constant concentration when we deliver the material to the plant. The material has a D50 around 35 microns, and these are the start and end parameters for the operation. So we start fairly close to the plant with the elevation difference between the TSU and the plant of 70 meters, and this increases to 140, and the total transportation difference goes up to 2,500 meters. Well, this is a sketch of that operation, where you here see a sketch of the pressure drop over the operation. So at the start, we can easily, with the pressure created by the HRHD series pump, we can easily pump the material to the processing plant and have sufficient inlet pressure available to deliver. If we go then very, very deep in the mine, at some point we need to add an additional booster station, which is a similar pump as would be installed on the TSU. As you can see here, the pressure drop goes down, and then it's repressurized by the booster station, which makes it, it enables it basically to transport the material at the desired rate and the desired concentration to the processing plant. Well, the costs associated with this operation are here depicted as annual operating costs, and again the start of the operation and the end of the operation. And if we add up all the energy, maintenance, repair, personnel costs, etc., we end up at $1.79 US dollar cents. This goes up to just over $2 towards the end of the operation, due to the fact that an additional booster pump would be required. We have estimated this with a 25% accuracy, and we expect for other operations that this will be the order of magnitude for operations. So to wrap up my presentation, we've seen that saturated tailings and soil-like material can be easily and effectively be transported using slurry transportation. The tailings certification unit combines conventional dry excavation techniques with proven dredging technology to improve the overall transportation method. We can install a booster pump in series to enable tailings to even overcome greater distances and elevation differences, which is a small add-on to the operation, which is relatively easy to implement. The IHC HRHD pump is capable of pumping tailings over large elevation differences due to that increase in manometric head that it can produce. And we see that pipeline slurry transport is a very feasible method for tailings at low cost and a low carbon footprint. Thank you very much for attending, and have a good day. Thank you very much.
Stefan, thank you very much. That was great. Stay connected for further discussion. Уважаемые коллеги,
Dear colleagues, so following Stefan's presentation, I do hope that we'll have some questions or comments on the topic that has been raised. And we have now learned about these methods and also ways that we can use the technology. And then we move on to transportation. And then the transportation will be followed by concentrates. That what this is going to be the next stage. So those the ideas and just contemporary methods that can be used versus conventional ones. And with that, I would like to give the floor to our colleague Mikhail Leskov. Just between our companies, between IHC Mining and the Institute of Geotechnology, it was in 2018 that we entered into agreement on partnership and collaboration. So the Institute for Geotechnology is actually our partner for all the projects across Russia and CIS, so in terms of consulting projects, and we would like to express our gratitude to the company for the adaptation of all innovations and solutions that actually are very vital and are very crucial to the Russian market and the needs adaptation. So if you remember that Henk van Muin started our masterclass, so together with Mikhail Leskov, I would like to say that they have this long-standing partnership that started last century. So there's expertise is there, so lots of things to share. And Mikhail, the floor is yours.
Good day, esteemed colleagues. My presentation will be built mainly on the materials of an IHC company. That's how we call it, IHC. IHC. We like this name, and we are working together for more than 20 years. Henk and me, we started to work together, and we come in the same way. We want to become the marine sailors, but we were attracted by drag, and that's why we are now within this recovery industry of the solids. So my profession is the designer of the recovery factories, but I would speak about something which I'm very interested in. But I will speak about the designing a very specific plants, floating plants. And here you see the agenda of my presentation, the structure of it. And I think that we'll not just make a presentation, but we'll have a discussion after it. In a couple of words, of course, the specificity of this discussion or this conversation, what I've said, that mainly the solids are extracted with the dry method. And we'll be talking about the different structures which are located on the sea. Initially, we want to apply the different trucks, then the bucket, leg draggers, stationary built units. Although we have a very long distance for transportation, and becomes more and more when we go deeper, and the spirals, thus we see the increase of costs and a kind of burden for any kind of the site, and we need also to take away the water from them. That is why we can either move forward together with the plant, and we can keep the same distance within the mining and the plant, processing plant, and we can do it in a very close distance, and to put the tail such a way that 2 years after at the beginning, at this point, you cannot find any traces, no footprints on the earth. So this is the main idea. And technically, we can save time, money, our efforts. If we apply these technologies, also we can use very low number of employees and be at maximum with our capacity and productivity. That's why how to move the plants after the phases and how can we do it. So for the first time we see this experience of the separate floating plants. It appeared about half a century ago, and we based on the experience that was accumulated in the companies like IHC when they designed the classical multi-bucket dredges, and the processing plant was on the same ponton, but of course it must be heavier. This ponton is not flow flexible, and they have to go through from the phase to the wet to the processing unit, so it complicated the process. Now we appear the idea to place them separately, that we start the mining on one part and processing on the other one. So the first idea appeared in IHC, and for the first time it was applied in titanium and zirconium sands, how you can see at this picture. And the dredge as a tool and floating plant, which is on the self-standing ponton, and after it the tailings were placed and recovered after it. This idea has been developed, and now it applies for the man-made projects and for the other primary virgin projects, both for the alluvial and for the virgin and tailings deposits. And here on this picture you can see how it can be done on hard rock tails in Germany. On the slide you can see this dredge, and behind it you can see the boat that brings the end product to the shore, and sorting unit that sort out the sand and gravel. This is maybe the maximum in size, but one of the shortest in terms of technological chain. The example of the floating plant, it can be applied for the wide range of commodities, and also in many cases this can be applicable. For instance, here you can see the floating plant on tin in Africa, which is loaded from the shore. Hank presented in his slides one of such options, and speak about it later. Here these floating plants may be used for the aggregate sands and gravel. They'll also for the oil sands to get heavy minerals out of oil sands tailings, also titanium minerals from zirconium from the tailings of processing oil sands in Canada, both for the gold, also for PMG, for the diamonds and for the tin, and for a number of solid minerals. So we can use a lot of different types of floating equipment. Here you can see one of the versions that was prepared for one of the companies, and the former director of this company is here, and maybe he recognized this floating plant for the mining of platinum and metal deposit, and it was meant to replace a big number of standard equipment that was used at that time. And they are still used, but the idea was to replace this old equipment with a number of such floating plants. And here we see it with a screening, search bin, and spiral concentration. Of course, the search bin can be, instead of it, we can install some either units or separations or different. So the set of the equipment can be very different. And you see here it's without the cover, without the body. It can be performed in the winter version with the insulation inside, with the warming or diesel units if you need any kind of energy supply. Here you see the scheme on bottom of the image, how it can be placed, what type of, in what sequence we use this technological process, how they can be put. First of all, we take away then the dragger with the floating plant, they operate on the productive layer, and then they lay the tailors beside, then over it there's overburden, and then we plant the trees, and you see thus we recover the area, as I already told, from the very beginning to the end of the process with just several years, not dozens of years like it happened now, and sometimes even more than dozens, because what we do instead of this, after the mining, we just try to recover the land. And of course, it's much cheaper. There's no need to pay for the whole land. And the distance for transportation and all other operations can be minimized to a very low level when we can apply this when we're dealing with either with the very wide areas and very low capacity of the deposit, with a not very deep, with a not wide layer of the productive layer, or when it is a compact design that consists, for instance, of the easy and cheap tailing disposals. And the main advantages of this, of course, that's compact design, simple relocation, very small stuff. If we compare with the classical operations, we need to have at least 1-2 excavators, then the loaders and some other equipment normally are needed, some dozens of lorries, then we have to multiply it on the number of operators, number of shifts, and so on. Then we have to add the personnel, the staff for the, servicing, all these engineers and operators. But here we just need 1-2 dredges, 1-2 very low stuff, and that is all. And then we have this pipe with the concentrate, and that is all. Of course, there's absolutely different projects, absolutely different rate of sinking and moving, and the profitability of such projects is very different, you can imagine. What should be taken into account when we think about the main factors to take if we compare different plant size, type, flow sheet selections? So what we have to keep in mind? First of all, productivity. The classical drugs, the maximum size, what we have, it's 400 liters in Russia. In IHC, they have up to 1,500 liters. It's continental. The seas may be even bigger than this. They're larger, with the depthness like 40 meters. Just feel the difference. It means that we have to apply some larger dragger and one big one instead of several smaller ones. It also depends on the kind of transportation, how you're going to feed the plant with either dry or wet method. There's mining method and equipment. And what we'll see, this solid wicket ratio in the plant feed and its stability while mining require. So we have also to think about the surge beam. Then we have to think about the clay slumps in the feed. They also will define your plan, because it's needed for your effective operation. Then the grain size distribution for the plant, grain size on the commodity. Then the number of concentration steps to allocate at the ponton, and what to do after it with the concentrate further at the shore, basically. So we have to place the minimum level, which could be rational and feasible, depending on what we are producing. So the number of concentration steps also should be taken into consideration. Then the tailing disposal arrangements also will impact the transportation. We have to think how to pump tailings and what to do after it. We have also taken into consideration energy supply. It can be done either for long term, it may be based on diesel or electric supply. There may be a combination of different energy supply sources. Of course, climatic conditions should be taken into account. In our climate, for instance, in Magadan region, for example, more to the north we go, the more important becomes the difference between the season for the dry and wet methods. The more to the north, then the difference is larger. Naturally, it's easily explained because water has the more heat capacity and it works better as a heater when it preserves the temperature, the certain temperature, and give us an ability to start the season earlier and to finish it later. And some other possible specific features must be taken into consideration when you make your decision. Here you can see 3 examples of what we have. The backhoe with the floating plant, then suction dredge and floating plant, and how it can be applied, then dry mining plus slurification unit plus floating plant. So the first, this is just for the small compact plants, but when you need the higher cutting force for the hard soil, which takes, but with the shallow mining, and the second deeper mining, but the conditions are milder, but the capacity is much higher, and the third option is the combination of different methods. Now talking about the CAPEX and OPEX. First of all, I have to speak about what is comparable. First of all, it is rather cheap option, and if to compare it with the classical offshore units and plants, everything what we see here is just pontoon, but what we have to remove from here, that there's no need to relocate the plant and then to reset the plant. When we're speaking about, for instance, gold mining, it really costs a lot. But at such approach, we don't have these costs. If we speak about the plant on the board of a drag, this we can use different equipment for this. Everything is much easier here and, of course, much cheaper. Now about the operational costs. We just have 1-2 operators here. Even if it's quite a big plant, there's no need in a staff there. It works practically automatically and requires very low level of maintenance. Of course, there should be some maintenance, but to speak about operation, current everyday operations, there is no need for a big number of people working there. And taking into account that it is very compact, there are no such volumes that should be ventilated or heated specifically when we apply it to gravitation processes. No need for, for the energy supply at a high level. So it means that OPEX is rather cheap, it's rather low. So in conclusion, what I would like to say, unfortunately, in Russia, we don't have the regular experience of application of tires floating plants. But fortunately, we do have such an experience in the other countries, and this experience is available. And there is not only IHC, which is one of the biggest owner of this type of experience, but IHC has an office in Moscow and people, experts, who can advise you, also experts in the Netherlands, and they are oriented to the CIS and Russia, and they are ready to provide their knowledge and experience. And I think it's really very interesting experience. I'm the engineer, the technologist. I think that is a kind of paradoxical. It's very simple, so simple that it's hard to believe, an option of application. And I think I see a very bright future for these techniques, and Russia is still quite a big mining country. And we have the alluvial mining for the gold, and we now have more than 70 tons, which is much bigger in many other countries. And that means that the scope of this mining, gold mining, can apply a lot of different technologies, including this one, and also when we come at the new spiral level of the technological cycle, the man-made deposits and recultivation of the oil deposits, old oil deposits. So such projects can be very profitable, sustainable, and allows you to obtain profit where it seemed impossible in the some time ago. So I think it's very useful to study this experience and also to apply it. Excuse me that the presentation was done in English because I didn't have time for translation, but if anyone wants to have this presentation in Russian, I will be pleased to present it to you. Mikhail Ivanovich, thank you very much. There is another very interesting separate topic for the discussion. And now I want to introduce, in the end of our masterclass, I would like to introduce our partner company, Tetra Tech. They are our partner not only in Russia, but also in the international market. And in the end, we'll speak about the logical supply. We have concentrates, what to do with them further, how to process them. It's a global topic. We are touching upon global topics today. And we'll speak about one of the methods. This is, I would like to represent Andrew Carter. He's the technical director of Tetra Tech company. Andy, are you with us? Please.
Right. Can people see the screen and people can see me? Yes, I think so. Good afternoon, delegates. Thank you very much for this opportunity to present something that I hope you will find interesting in relation to treating of gold tailings. First of all, I'll give a very brief introduction to Tetra Tech, who's part of the partnership with NSM and IHC. Mainly for those who aren't familiar with Tetra Tech, who we are and where we come from. This is not a sales presentation. I will skip straight over it. Okay, the topic of my presentation this morning is the Goldilocks process, which stands for Gold In-Layer Oxidation for Tailings Retreatment. This is a process that was developed some while ago, and I will go through the history, but maybe it's a process whose time has come. Outline of the talk today, a very lightweight talk. I don't want to make it too technical, but hopefully it will be technical enough for those delegates who enjoy the technical stuff. So a brief introduction to Tetra Tech, a little bit talk about bioleaching, and bioleaching in relation to pyritic gold tailings, and more on the Goldilocks process for recovery of gold from pyritic tailings. Okay, who and what are Tetra Tech? Let's just say Tetra Tech is a very large international consulting company centered in the US, but they are worldwide, and they have a very successful track record in consulting environmental and renewable energy. Okay, there are operations. We have 450 offices worldwide and about 20,000 employees worldwide. So a very large and widely distributed engineering and consulting company. This is our tagline, which is very dear to my heart: leading with science. I view ourselves, and certainly the office that I represent, we are primarily scientists, engineers, and technologists who also happen to do some consulting. Okay, as a company, needless to say, very large company, active in the resource sector. We're engaged with all aspects of mining throughout the entire mine life cycle. I'm sure this presentation will be available for people afterwards, and you can refer to this in your own time. And amongst our clients, you'll recognize some names there. We deal with a number of tier 1 companies and reputable companies, many of which that I'm sure you recognize there amongst our clients. Right, on to topic. So it's the Goldilocks process, but I'm going to talk a little bit about bioleaching and biooxidation. So many of you obviously know that it's a natural process, and it usually affects rocks containing sulfide minerals where bacteria grow naturally. So what you see here in this picture is an example of biooxidation and bioleaching occurring naturally. So here you see an exposure of sulfide containing rocks. This is in a cold climate, in a glaciated terrain, in glacial terrain, and it shows you that this process occurs naturally and continues to occur even at quite low temperatures. Obviously, it slows down and speeds up depending on the temperature, but generally it's a continuous process. So what about bioleaching and biooxidation? Well, believe it or not, it's been around a very, very long time. Those of you familiar with bioleaching and biooxidation will know that in terms of biooxidation, there's between 2.5 and 3 million ounces of gold produced annually around the world by biooxidation, and there's also several million tons of copper produced by bioheat bleaching. So in terms of the timeline, excuse me, according to Agricola, anyway, this process of bioleaching was known already to the ancient Greeks and Phoenicians. It was used extensively in the Middle Ages as the primary method of making sulfuric acid. It started being used more extensively in metals production in the 1930s with uranium, and then for secondary copper minerals. And then in the 1980s, we got a big boost with the development for the use in gold extraction, and in particular refractory gold, which is what we'll be talking about today. And then more recently, extension into other base metals. Of course, the big prize is chalcopyrite leaching, and there's a number of companies that have been successful in this area. And the green mining concept, certainly there's a future for bioleaching in mining, and we are currently developing a green mines concept that's based on bioleaching. So that's bioleaching will definitely feature in the future of the industry, possibly even more so in future. Right, this is just to illustrate that it's been used for many centuries, and there's been a reliable process when put into use. So this is taken from De Re Metallica, which every good metallurgist will have a copy on his bookshelf, book by Georgios Agricola. And here we see in the Middle Ages, people going about making sulfuric acid, which in those days was called oil of vitriol. And if you look at the main features of the process that they used, which was heaping up a rock, exposing it to the elements, turning it over, ventilating and cooling it, and then covering it and leaving it for a period of time, then even though in the Middle Ages they didn't know it was bacteria that was promoting the reaction, but they did everything we do to promote bacterial growth and oxidation. So bioleaching has a long, illustrious history, and it is somewhat strange that it's not used more frequently. So in relation to my colleagues who've been talking about tailings treatment and dredging, what are the reasons we might consider tailings treatment? Well, there's a lot these days, in particular with respect to environmental and social governance and corporate social responsibility directives. This is one of the burning fires in the boardroom these days, and executives are paying a great deal of attention to these initiatives. We may want to take environmental legislation may have changed, and we may have to take steps allowing for changes in legislations. We may need to do something with historic or current arising tailings in respect to operating and mining permits. Obviously, for environmental protection, there may be, as we've witnessed in some of the slime stamps failures in recent years, geotechnical and safety reasons for wanting to do something with our tailings. There's reclamation, and of course, tailings often contain metals of value. So metals recovery is often a big incentive, and metals recovery can be used to offset the costs of environmental rehabilitation and of reconstruction of new slime stamps. So that's a source of revenue. Okay, here's an interesting one. This one is from, I think, this photo is from a project in Central Asia. And what I want to show here, these are old pyritic gold tailings. And you can see this plant growing on it. And the point I want to point out, what I want to point out is that it's a naturally occurring process. The bacteria are ever present in the environment. And you can see here that you can see the oxidation, so that even though this is also in a cold climate, you can see that over time, the pyrite and that the ore has been, or the tailings have become oxidized. Down here on the left, you can see in the lower levels, the material is a lot less oxidized, but on the surface, it's highly oxidized. So this process we're going to be talking about is how we can harness this natural process in order to recover gold from pyritic and refractory tailings. Refractory is a term that's often used, people hear about. All refractory means is it's difficult to treat or it's resistant to treatment. There are many reasons for refractoriness, of which the three main ones are there. It could be because the gold is locked in silica. It could be because of the presence of carbon and preg-robbing materials. But more often, it's because the gold particles are locked in pyrite. And here you see a nice little picture of a gold grain locked in pyrite, and it's surrounded by pyrite and a little bit of arsenopyrite. So bioleaching or biooxidation is a process for the pre-oxidative treatment of ores. When we consider processing tailings, we have a number of treatment strategies. Obviously, as discussed by my colleagues, one of the most common ways is to look at conventional mineral processing, including gravity separation and flotation where possible. Oftentimes the grades are a bit low and do not support flotation. We can use hydrometallurgy, and hydrometallurgy is better suited to lower grade materials, in particular tails. These include processes like CIL and CIP. And, but in particular, where we have refractory materials, we need an oxidative pre-treatment. People will be familiar with biooxidation, pressure oxidation, or roasting, or one of those treatments. But generally, those processes are not suitable to low-grade tailings. And this is where Goldilocks comes in. Over here on the right is just a simple graph. This one actually shows biooxidation of concentrates. And all I'm trying to illustrate here is that down here on the left, where the material is not oxidized, the recoveries are very low. And over here on the right, where we have a high level of oxidation, the gold recoveries are equally as high. So the more we oxidize the refractory material, the more gold we recover. So what are we talking about in terms of bacteria? Bacteria occur in the environment naturally. They are everywhere. They are ubiquitous. You will find them everywhere, but they fall into these broad classes. Thermophiles, these are the high temperature bacteria. Mesophiles, which are the more common bacteria that you find, and psychrophiles, which are your cold temperature bacteria, like you might find in glaciers and elsewhere or in Antarctica. And all I'm illustrating here is the temperature ranges over which these bacteria operate. So they can operate some fairly cold temperatures up to obviously very high temperatures. However, for us, the ones that we're interested in are mesophiles and psychrophiles. These ones over here, I won't dwell into this. This is a lot of Latin for those who are interested, but they form three main classes: Archaebacteria, which are Sophilobus, Metallosphaera, and Acidanus bryolei. Protobacteria, the one most people are familiar with, Acidothiobacillus pharoxidans, the thioxidans and thiobacillus, and also true bacteria, which are your Leptospirillum and Sophilobus. And over here on the right is generally what they look like when you look at them under a microscope. A little bit of chemistry. I won't dwell on this, but this just shows you how the bacteria attack pyrite using oxygen and air to make ferric. So here we have our pyrite, and it's been oxidized through to ferric sulfate. The ferric sulfate then attacks the pyrite. Here's the pyrite, the ferric sulfate. This generates some elemental sulfur. And then the bacteria essentially oxidize the sulfur through to sulfuric acid, which they like, and they oxidize the ferrous that's produced over here back through to ferric. So it's the ferric that is doing the oxidation mainly, and the bacteria are essentially involved in a cycle to recycle ferric and keep the process constantly supplied with ferric ion. So what I'm relating here is the GenMin experience. What was GenCore? This was some work that we were doing concurrent with the development of the BIOPS process. I was involved in the early days in the commercialization and development of the BIOPS process, which is now, of course, owned and operated by Outertech. But in those days, we were looking at various systems, and one of them included this in-layer oxidation process. This was generally worked on in the late 80s and really has not drawn a lot of attention since then. But one of the things about this process is it lends itself particularly to the treatment of tailings and tailings dumps. And the tailings dumps can be treated and processed using very simple type of equipment, low capital cost, low tech equipment, generally agricultural. So it went through the typical testing phases from small laboratory, large laboratory scale tests, and it was tested at full scale on slime stands at the Ken West operation in South Africa. And as I said, low tech, easy to use. And here's the some illustrations of the type of implementation that's implements that are used for processing it. So essentially, how does it work? Well, as long as you can get onto the material with vehicles, it's easily worked using conventional agricultural equipment like tractors and plows. In the trials that were advanced, there were two strips of material that were tested roughly 9 meters by 50 meters, and they were separated by a bit of 50 meters give access. And the first thing that was done is the material that's already oxidized, like you saw on the previous dump, the oxidized material, that was taken straight off and removed and taken straight away to the CIL plant for treatment. Then we actually use the bacteria that's already living in the tailings to start the reaction, to inoculate the reaction below. And we do this by ploughing the mixture back into the surface, so to a depth of about 0.5 meter. And you end up with roughly 1/5 or 22% of oxidized material that's been pre-oxidized and which contains a existing bacterial inoculum that's alive. And those bacteria are then ploughed in and they are used to start the reaction on the layer of tailings below. Irrigation is conventional, except compared with normal heap leaching, the flows are very low. The tails are irrigated with an acid solution, just a small amount of acid, to which nutrients are added in terms of nitrogen, phosphorus, and potassium. And these are your conventional fertilizer, commercial brands, BioGrow, something like that. So the nutrients are actually very cheap. And we allow the bacteria to go about their business, do their thing for anywhere between 60 and 120 days. And then after the material's been oxidized, we come back and we remove about 0.3 meters with the grader or the loader. And then we plow that material in again to start the reaction on the layer below. So by a sequence of rotation and oxidizing in layers, we generally take the slimestone down layer by layer. We oxidize it layer by layer and take it down. And as we remove the tailings material, we transfer it to the treatment facility for recovery of gold. So what kind of results can you expect from this type of process? Here are the actual results from the full-scale trials that were conducted at Cambridge. And over here on the left, you can see this is the cycle time in terms of days of oxidation. Here is the gold dissolution at those days. And so you see for test A2, test B2, A3, B3, and so on. So these are the gold extractions after using cyanide, after treatment of these periods. So you can see that in a period of between, let's say, 60 and 110, call it 120 days, we can get anywhere between 60 and 75% gold extraction, which is quite commendable. The one thing I will point out here is the sulfur, the grades. You do need sulfur, obviously, and pyrite there to drive the process, and probably somewhere between 1 and 1.5% sulfur is ideal for this kind of process. There we are, the data's on there. So after about 120 days, you get roughly about 50% sulfide oxidation, and you can get, at that, you can get between 70 and 80% gold extraction achievable. So the question naturally arises, what about cold climates? Well, I think I've shown you that this process continues at low temperatures, although obviously at a slower rate. So what you can do is in your tailings dam, there will be existing bacteria that are busy growing there and oxidizing away. And so you can isolate native bacteria from your existing slimestones. You can adapt them to run at lower temperatures. By pushing the bacteria to oxidize at lower and lower temperatures, you end up with a very robust, very strong bacteria, well suited to industrial processes. You can adapt the moderate thermal fires to lower temperatures, as I said. But what is implied by lower temperatures? You tend to get slightly lower rates, which means the cycle times may be extended. But there are other things you can do. For example, there's nothing to stop you oxidizing under plastic polytunnels, like you might find also in the agricultural industry. People may ask, well, what about cyanide? Aren't the bacteria affected by cyanide? Well, the answer is yes, but usually in old dumps, the cyanide has been naturally oxidized. Cyanide is broken down by ultraviolet sunlight. It is also removed by other bacteria, in particular cyanobacteria, which are responsible for the breakdown of cyanide in tailings dumps. And that enables the other bacteria to get established. And it is also possible to adapt the bacteria to increase their resistance to cyanide toxicity. And that, so adaptation of the bacteria is an important part of this kind of process. And as I pointed out, you need sulfur, you need sulfur to drive the process. And as long as you've got somewhere between 1.3 to 1.5% of pyritic sulfur in the tails, then the bacteria will live very happily and continue to oxidize the material. There you are. Thank you very much for your attention. Thank you for the opportunity to present this interesting process. Thank you.
Andy, thank you very much. That was technical enough, and obviously nobody can disagree that green technologies are becoming more and more demanded nowadays and definitely for the future. Итак, уважаемые господа, коллеги.
So, dear ladies and gentlemen, you have listened to four presentations, to 4 our speakers. We have 4 topics, and this is a wet mining, hydromechanization, hydrotransportation, floating plants, and the last one was Goldilocks process. Unfortunately, we have very limited time for the discussion. If there are any questions, please. Just my first question to you. What is the most interesting topic for you? What would you like to discuss? And do you have any questions to any of our speakers, please? Сейчас уже. 57. Whoops. Good day. My name is Rodionov Anatoly. I represent the company our Rudnik Kopelkova. We are also involved in alluvial deposits. I'm interested in a topic that is about the bucket ladder draggers, because for one of our deposits, we're considering one of the options. We were not aware about your company. Just our operator, our technologist, he himself had this idea to use this type of equipment. And I have several questions. What is the percentage of the recovery when you're using your equipment? I think yes. So I think, Mikhail, the question is to you. You can no, you cannot just give the direct answer, because deposits differ, the minerals differ. And also we have to ask what is economically reasonable level. From our practice, it's from 80 to 90% recovery in concentrate. But what kind of concentrate you can obtain on the plant, this is the next issue. But we have to look at the certain deposit, on the size of it, on the resources, the quality of the resources, how it's distributed, the gold of the grade, and also the recovery ratio, because, there are different types of the grade that can impact, and sometimes it's rather difficult to capture this type of small particles, for example. It can be recovered, but you understand the coefficient, the ratio will be much lower. So we have to take into account all these points, and then we can give you the answer, whether it's really feasible economically and what will be the percentage. That's my answer approximately. Or you need more details? I can comment a little bit on this. Quite regular, we faced the situation that someone was going to achieve the same, aim, but they're not aware about us. So first of all, they look at this, dredge equipment, but they're very different. Anyone, if it looks at the loader, they will understand which one can be used in the mountains, in mining, and which cannot. With, the dredges, it's much more difficult because people are not so experienced, and quite often they use the equipment which cannot be used for mining, actually. They choose the wrong cutting element, physically the wrong structures used, and thus they are unfailed, you see. They purchase the equipment, but it's the wrong equipment, and we see it's absolutely failure, no project. The same happened with the floating plants. You see, nothing tricky about this. For instance, we'll replace the unit what we have on the pontoon, and quite often what we see that nothing happens again, because the balance is not taken into account, no stability, things like that. Vibration may also happen because some of the gravitation equipment can be very sensitive to vibration. There are different separators that can be stable for this. So there are a lot of small traps, and you must take into account them. But people prefer to learn their own lessons instead of applying the experience of the others. But we propose, please, study the experience of the others, and they apply it to your own, activities. So if you have any kind of, incoming data, provide us with this, and we can provide you the consultation. We can advise you about it. We just need some incoming data from you. Oh, thank you very much. Yes, that was very, very full answer.
For me, no, I think that Michael perfectly explained about, let's say, the possibilities, the recoveries, etc., and the criteria which are of importance to determine what kind of equipment and solution you should use. But it's always, as he expressed, very important to look at the circumstances, the constraints, and then determine the proper way out, the proper selection process. Follow that in order to come to right possibilities, and also look beyond your experience. Russia, they have a very long experience on alluvial mining, for instance, alluvial gold mining, but you have to expand your thoughts and look at all the possibilities which are developed globally.
Коллеги, еще вопросы к нашим докладчикам?
Colleagues, do you have any more questions, please? You're welcome. Thank you. Severov Vyacheslav, the first mining company. Svetlana Borisovna, maybe ask the first questions to you. That's my first question. Please tell us, do you have any projects that are used, which use dredges? Yes, we do have some historical dredges, but they can be used in the modern projects. About the modern projects, we do have a project which is not completed yet, I may say. I'll explain. We cooperate with the largest Russian gold mining company, and for this company, as initial stage, we developed methodologies and technologies to increase their productivity, and of course to increase their production, gold production. And this methodology, we have revised some of their technological schemes, and also we include some additional equipment, like, for instance, high recovery machines that were supplied, and it increased their productivity. High extraction machines. If they would additionally use the potential what they have at their full capacity, then it will still improve the recovery. So this project included this renovation of their dredge fleet, not only purchasing of the new equipment, but also recovery or refitting of the historical equipment, so-called historical, very old one, which can be compared to a monument that was not used for quite a long time already. So this project now at the stage, part of this project has been implemented, and the other part depends on the investors, on the shareholders, stakeholders, and their decisions. One more question to Mikhail. Mikhail, do you know the project quite a long term? Sevmor Olovo, Tin, do you know them? Why it was a failure? Yes, of course I know this project. Very old one. I was involved into it in Lapteva Sea. Very interesting, deep water mining. What we called remote operating vehicle. They use tank 155. I'm a tank driver. That's my second, education. Second drive. I have a driving license. It weighs 40 tons, but it was floating, and we have to put additional lead plates on it in order for it to go deeper under the ground. It was in the end of the 80s. It was the beginning of the 90s. There were a lot of different solutions which are now already well known in terms of technology, equipment, and materials that they used, so they have improved very much. But at that time, they were not known. But now we have different practices, we have standard solutions. Just want to add that to a large extent, the activities and works are now accumulated on the offshore deposits, the tin, zirconium, and some others, very specific materials. Abrasive and seawater, and very deep in the sea and waves, and we have to take all these factors into consideration when we're dealing with this type of deposit. It's very interesting experience, by the way, but unfortunately that is not our experience, but technically it is available and is applicable and should be applied. Unfortunately, we are very pressed of time, so I just would like to come back to the question that I asked in the very beginning, if you remember, at the beginning of our masterclass. Water, what do you think? Is it an enemy or it's a kind of helper to you? What do you think now after the presentations? Can you vote maybe? Can water be beneficial or it's still against your activities? What kind of opinions you have? Do you still follow the traditional approach, or after our presentations, our masterclass, maybe you change your opinion, maybe you look differently now at different schemes of extraction, processing, and transportation? Again, what do you think? Is water still an enemy, or we can apply these new technologies? Please vote. Are you for or against? In favor of water or against it? What would you say? Can I just say a few words? Water can never be an enemy because we are surrounded by water. We use a lot of water as a transportation channel. And we now consider for 15 years already that we're going to use the deep water mining, and now a lot of experiments are done in this field. And there are some unique, solutions that allow you to make the mining at 5.5 kilometers. And as far as we see some, depletion of the resources, the same happens with water. So I have two questions: technological solutions, and secondly, environmental issues. We have to protect the environment. So if in future these two aspects will be put together, then I'm sure that water will become our friend, and in very near future. So we have no way out. We have to look for the partners and for the, for those who can support us. We have to work together. More questions, more opinions. So if not, then thank you very much. We'll be happy to see all of you at our booth tomorrow and the day after tomorrow. IHC mining, or IHC, that's it sounds in Russian. So all of you are welcome. Please come to us and we can discuss all these issues in details and more questions on top of this. And to conclude, I want to mention that we have a number of publications devoted to these topics. If you look at the table in the corner, then you can find these publications. Some of them were done together with the Institute of Geotechnology. Some of them are our publications. Please take them with you. So take away. We'll be happy to see you again.